Hello, everybody. Welcome to episode 27 of MakerCast. That's awesome. Okay, I am your host, Seon, the Unexpected Maker, and we have a awesome assortment of guests on this episode. So I'll let everyone introduce themselves, starting off with Simple Electronics.
Well, hi everyone. I'm Simple Electronics. You can't see me, so this is my stunt double. I'm just trying to stay anonymous. That's why I'm not on camera. And if you've ever watched my channel, that's it's kind of par for the course. And you can find me at youtube.com/Simple Electronics. Thanks for having me on. I'm really excited to be on the my first MakerCast.
It's great to have you here. Chris?
Sure, so I'm Chris. It's my first MakerCast too. So you can find me on YouTube on Atomic14 and on Twitter I'm Mr. Bananas, which I'll probably explain later. But thanks for having me on, and it's great to be here. Looking forward to it.
Awesome. Liz?
I'm Liz. YouTube channel is Blitz DIY. Do electronics projects, 3D printing, things like that.
Cool. Timon?
Hi, I'm Timon, or timonsku on Twitter, or Professor ProfSparkles on Hackaday.io, and I'm electronics designer / maker / everything, kind of what's fun.
Cool. Deshipu?
I'm deshipu. I'm Radomir Depiralski, and I'm mostly Python programmer and electronics hobbyist. I don't have a YouTube channel, normally.
You need to create one, I think.
Agreed.
Yeah, do it.
Yeah. And I'm Seon, Unexpected Maker, electronics, hardware, software, 3D printing, laser cutting, all the maker stuff. But you're already on my channel, so you probably already know that. Okay, we're going to have a chat about some of the projects we've been working on over the last month or longer. There's no time frame, or it could be something that's upcoming. But we're going to start off with Timon because he's got some exciting news. Go for it.
Yeah. So I mean, it's not completely new for those who follow the MakerCast. It's been like nearly 4 months ago, and I think that was when Liz was hosting that episode of, I think, December. I showed off a little board, the called Pionora. And it's a carrier board for the Compute Module 4, the Raspberry Pi Compute Module 4, which is this little green thing here, if that focuses. And that is essentially like a tiny pluggable version of the Pi 4. It's like intended to be like integrated into like custom products, custom form factor. So it's like just the CPU, just the RAM, and the Wi-Fi module. And that kind of started out as like essentially a weekend project. I got some time back in December to like get back to designing some electronics, and I got that idea initially from Scott Shawcraft, who just mentioned casually on like, I think it was Edith Show and Tell, that it would be cool if someone would just make an Arduino form factor board for the Compute Module 4 for like CircuitPython stuff. And I thought it was a cool idea, and I thought, okay, that sounds simple enough. And I just got started with that. And initially, I thought just like put USB on there, at the Arduino pin headers, and that's it. But the more I was working on that, the more ideas I got for that, and it was kind of cool what you could put on all of this little form factor. So it got USB here, HDMI, the SD card connector, and then on the back, you actually have an M2 connector for like PCI Express, and also USB. And that's why here I designed a little carrier add-on for that, which is for the RP2040. Oh, I have it here. If you can see that. So that's like the new Raspberry Pi. No, not the background. The new Raspberry Pi microcontroller. And I was experimenting with like just like finding out if it's feasible to like make a little add-on board instead of like a shield, used like this M2 connector. But unlike, if you know, like the SparkFun micromod, they use just a connector and have like their own pinout defined. And here I try to like stay with like the M2 pinout. So you can technically could use that in a laptop if you wanted to. Yeah, and then we also have a camera connector here, like the full size one that you get on the big Raspberry Pi. And that kind of developed from, yeah, this fun little weekend project that I showed off in December to, yeah, a whole product, because people were quite enthusiastic about it, which was really cool. And I ended, yeah, founding a little like side company, which is, yeah, called Diets Delight. You can see on the front here. That logo is, by the way, designed by Blitz, which you also maybe know from the MakerCast and other places, and I think she did a great job there. And yeah, so yeah, I've started setting up a company to be able to sell stuff, because in Germany you can't really sell anything if you don't have a company. That was a whole process, and yeah, I thought I might share a little bit about that, because I feel I get these questions asked quite a lot, like what the process is, because it's very bureaucratic in Germany to sell, especially electronics. So one of the hurdles is, yeah, basically also the reason why I went with crowd supply, by the way, is in Germany or in Europe in general, if you produce electronics, you are obliged to take them back and recycle them, which in itself is fine. But the way that system works is you basically get a huge shipping container full of electronics waste, and you have to get rid of it. And, you know, it's just this like round robin, like every manufacturer has to do that sometimes. Of course, as an individual maker, you can't deal with that kind of stuff. And it's, yeah, for that reason, nearly impossible to like organically start very small. Like you would have to immediately like pay that amount to like a pay amount of money, like 1,000, 2,000 euros a year, to some service that would take care of these kind of things for you.
So are you saying that like an individual who's bought your board at any time can say, I don't want this anymore, I can send it back to you to get it recycled?
Yeah, not like that also theoretically, I think. But in general, it's like the way it's set up. So instead of like customers sending it to individual manufacturers, they can just give that away anywhere. And it's like collected, and then, yeah, essentially really literally a shipping container can be placed at your door, and you have to like recycle that. So,
so
you
there are
get
places
trash
they can
from everyone, basically.
And it's just random electronics junk.
Yeah, everything that like gets collected in general. And so it's like the idea is to like share the load between all the manufacturers. It's not the manufacturers, it's the distributors. So everyone who sells electronics. But that's usually like if you're starting out, I think the most people I know, they sell on Tindy or something like that. So like, you're also the distributor, so you are liable for that process. And that's usually fine if you're like very small, but as soon as you sell like a somewhat sizable amount of numbers, someone will come knocking at your door, and that is annoying. And there's the reason why I do not sell why I don't sell in Germany at all at the moment, and don't plan to in the future. So I'm only selling at the moment through distributors, so crowd supply at the moment. So I'm currently running a crowd supply campaign to like get the initial money together for the first manufacturing run. And that allows me then, Mauser is behind crowd supply. They will then import everything into the EU, and they take care of these, the electronic waste requirements, which is really handy. And I can recommend anyone who wants to get started with this, find a distributor for yourself that will take care of that. It's fine to also sell yourself, but keep in mind that it's like there's a lot of bureaucracy behind that. And my personal recommendation there is do that maybe later on. Get started, find a partner that does all of that stuff for you, and if you got have a couple of products on the market, then maybe think about distributing yourself if you're interested in that. I'm not. Like, I'm really interested in the design process. I like manufacturing, but everything after that is not my deal. So I gladly go to the distributors like Adafruit, Primaroni or so, and ask them, hey, do you want to carry my product? And if it's an interesting product, I think it's not that hard to get it into these places. So
Cool.
that was the whole process there. So like the past 3 months, I didn't really do much of electronics design on this. Like I changed some things, added some features, and like look for cheaper components that are more suitable and all that kind of stuff. But most of the stuff's just communicating with so many people and lots of talking, which you might not expect.
Oh, it's I've said it before stacks of times. Like you design something, like selling a product, getting a product out. Like majority of the work has nothing to do with the electronics design or anything else. It's all the extra work you need to do to ship a product that takes ages. Yeah.
For sure. Especially if you're doing you're doing a lot of your stuff yourself. Like talking to a contract manufacturer that's maybe in a completely different country than you, and getting across like your design intent and like what's important for your product and what should be tested and like all of this stuff. It's like a lot of communication work that needs to be done there.
Yeah. So I had a question from Shaq. Wants to know if your board is open source.
Yes, it will be fully open source. I tend to not share open source until it's done, because in the past people have been very trigger happy about like producing PCBs that are just not tested yet, and then asking me why stuff isn't working. I want to avoid that, but at the very latest, when it's shipping, everything will be released. And I already shared the schematics on Hackett.io if you're interested in that.
Awesome. So I posted the link before to the crowd supply campaign. It's doing pretty well. 30 days left, and you're already over a third of the way, almost 40% funded. So,
yeah, it's going pretty okay. That was nice. Right, and one more thing that I wanted to like maybe get into, because I think it's kind of interesting, because it's kind of I see a little bit of a trend there. Like I mentioned briefly, like one of the motivations for this is, or like why they are the uniform factor in general, and that was like I'm interested in making something that is electronics friendly, combined with Linux. And in my opinion, that there is very little on the market. So the only thing I know of is the giant board from Grogwart. And I think, but that uses something like a processor that's not very well known. I feel like the Pi itself is a bit more accessible to people. And it got a bit of like graphics power, so you can still like attach a keyboard and stuff like that. But what I find really missing from the main Pi, it's not that cool for like electronics prototyping. Like you can do the things, but it's not the same experience like you have with a normal dev board, where you plug it into a breadboard or something, or they have like just the simple fact of like legible pin labels. You can see here, like you can see what pin is which. You get the pin numbers, you get everything is, oh wait, that's the wrong version. It's the first prototype. So everything is labeled clearly, so you don't have to like look up a website, check like count the individual pins. Okay, pin number 14 is the SPI output. Like it's nice, like little things, but all of these little things kind of add up. And I think CircuitPython is a great language for electronics prototyping, or a great ecosystem. And what I really like about that is you plug these boards into your computer, USB storage device pops up, and you have a Python file there. You open it up, you code, press save, and like instantly executes. And This is such a quick, cool process. And the cool thing with the Raspberry Pi processor, you can actually use it as a USB device. It doesn't have to be a host. So what I added is, if this focuses again, you can see this little switch over here. And what this switch does, it switches over the USB data line from the USB-A port to the USB-C port. So if that is in the device position, you can just plug this into your computer, laptop, whatever. And with a little bit of software that I'm currently writing, a USB storage device will pop up after it's booted, which takes about 10 seconds. And you can open a serial terminal, and you have the same workflow there. You don't have to find out like a Wi-Fi IP address or hook up a monitor on any keyboard. Like all of that labor is setup times like cut away. And I think that's really quite cool for like, prototyping with a really powerful processor. And that's kind of what excited me about like the idea here. The compute module in general.
Okay. I got a couple of questions.
Sure.
The first one is, what are you doing for things like analog? Because there's no analog pins on the Raspberry Pi.
Oh, right. Yes, good question.
That the Arduino requires for compatibility.
Let me pull out the module here, because the other one doesn't have the ADC. But you can see here. Oh, come on, focus.
Focus.
There's a little IC that is an ADC. So you get on the usual positions, you get the analog inputs.
Okay.
The only difference, you can't use them as digital inputs like you can on an Arduino. It is analog only. And you get 2 extra analog inputs on the bottom here. If you're hacky, you can solder that. I didn't want to waste these 2 extra channels that the IDC has, so those are there too.
Okay, cool.
So yeah.
Well, the next question is, what are you doing with silicon supply? Like,
quite okay, actually.
Sorry?
So it's mostly a mechanical product. So if let's have a look at this. So on the top side, we have the ADC. That ADC, it's all mirrored for me, so my brain doesn't really keep up there. That ADC is a microchip MCP 3008. It's a very old process, very old part, and it's really not affected at the moment from this whole chip shortage. Other than that, all of the other components, we have like a USB MUX here, which is a super generic part. You get like 15 manufacturers that make a pin compatible part. No worries there. Other than that, there's a little inverter here, also Jelly Bean part. Tons of manufacturers making that. The only thing I'm a little bit worried about is this buck converter here that converts 5 volts to 3.3 volt for the M2 port, because SSD storage takes often quite a lot of current. So I kind of needed that here to make that work. And that chip is a little bit more in the automotive industry, which is kind of sucks, but it's still available. I'm currently in the process of buying all the stock there.
Right, okay. Cool. Excellent. Cool.
Oops.
It's been great to see this like evolve, because I hosted that December episode and you had literally just like whipped it up like that weekend or the weekend before, and we're all like, this is awesome.
And renderings back then.
So it's been really cool.
Thanks.
Yeah. So if anyone's interested in backing it on Crowd Supply, head over to the link.
I'd really appreciate it.
Yeah, it's cool. Okay. So let's move on. I'm going to get Liz up next. You've been doing some exciting stuff.
I've been working on a couple things. So one thing that I did recently was a Pico Midi fighter. As the collab with Nairuaz for Adafruit. He designed the case. So it's using Raspberry Pi Pico, and then it's got 16 arcade buttons. And the other thing is it has this screen here with a toggle joystick, so that you can change the MIDI note like on the fly. Because before you'd have to go into the code and everything. So if you're doing live stuff, it makes it really handy for like shortcuts with your DAW, or if you want to like change up what notes you have available. And today I modeled up and 3D printed some eggs.
That's cool.
Oh, now I'm hungry.
So I've been thinking for a while, like eggs would be a really cool 3D print, because you could do a color swap for the yolk. So I had an egg for lunch, and I was like, you know what, I'm going to model that. So it just did some splines for the whites, threw in some like little holes for magnets on the back. And printed those. I'll be sharing the file for that eventually.
Very cool.
And then another thing I did, the Sailor Moon Star Locket. I don't know if folks are. Well, I didn't mean to, but I wore a Sailor Moon shirt. But it's an anime, and this is a prop from the show where might show up a little better on Seon if you want to share my screen. Yeah. So there in the show, there's like this locket thing with a moon that goes around. I think it's supposed to be like magic. So this is using a Circuit Playground, Blue Fruit, and the Gizmo screen add-on. And then I modeled up this case, so it has access in the back to do the screws and everything, power switch and a speaker, and these little recessed bits for pressing the buttons. And so I'll just quickly do when you press it, it plays a little music. So that's a little thing. Then played a bit with Raspberry Pi has the wideband support now, so you can watch like Netflix and Hulu and everything without doing weird stuff, and it actually works. So that's been exciting, and I'm starting to play with doing like a custom like Linux mask for it, so that it'll look more like a media center. And then Nae modeled up this case that looks like a VHS tape.
That's awesome.
Which, wait. You might have to explain to people what a VHS tape is.
Yes. Back in the day, there were these plastic chunky bits with tape inside that you'd go into a box and it would display moving pictures on the screen. So this has a little tape insert. I did a filament swap, and I had to glue mine on top because my printer can be a little loose. But I think they modeled so it can snap. But there's that.
And just quickly, the best feature of the VHS tape is when you eject it, but the tape half stays in the machine, and then you get spaghetti as you pull the tape out. Do you ever get tape jams?
I never experienced that, but
really?
That sounds scary. I actually digitized all my VHS tapes. Legality on that is a little gray, but a couple of years ago, and a lot of them were Sailor Moon VHS tapes, and then like all the Disney ones, everything like that. Cool. And then one more thing I'm starting to work on. It's not like complete yet. If you want to switch back to my screen, I do a lot of musical robots. And so this is one I'm working on right now that's a recorder bot. So it's an air pump here. And I don't have the solenoids hooked up yet, but basically there's going to be this apparatus here that will press down to cover the note. So I'm working on that, and eventually it'll be like MIDI controlled. And I'm going to switch what I'm sharing because I did some CAD work yesterday to make the stand a little more. Well, there are my eggs. So this is the new design. They'll make the recorder a little more stable because it has two mounts. And also the mounts now will screw in on the outside here because that was one thing with that. I modeled it so that the screws were like underneath the recorder, which was not ideal. And the way it's working is the solenoid mounts on the side here, and then there's this bracket that's holding the flexible filament strip, and that's what's pushing down to cover the holes to change the tuning. So that's in early stages, but very excited about it. And that's kind of what I've been working on.
I like your trend towards midifying all the instruments.
Yeah, and what's the other thing with the recorder too is like in schools in the United States, like we learn how to use that in like the really early grades in music class. And one thing I was like thinking about like other instruments to robotify, I guess, is with this, I mean, there's probably some kids that because of physical differences, like they can't necessarily play the recorder. So like this, although it looks like kind of silly, like it could kind of be an accessibility thing, which could be nice. And also with COVID too, people haven't been able to do instruments in schools because of like worries about contamination and stuff. So this could be like a fun way to demonstrate how the instrument works without having to worry about some of those barriers.
With the design, what like is there a reference design for a wind instrument that you can 3D print that plays the right sound? Like,
I haven't seen anything. Sam Underwood on Twitter, he's done a lot of work with more wind instruments, mainly brass. And one thing he had done, we were chatting a bit, was he's used like a kind of a slide cover for instruments like this, so that like you're kind of moving a cover down to reveal the different holes.
okay.
So that's one way you can do it, but it's not as popular to do as like with the percussion instruments or even stringed instruments. I think are getting more popular too. I saw Ivan Miranda did a guitar video, I think.
Yeah,
this
and he
week.
just did a drum one as well. Yeah.
Yeah. So this is a little wonkier, and I feel like that space is already kind of wonky. So this is truly like very weird. So I'm excited about the CAD work I've been doing. I haven't really done like an assembly like that before. So just with the first draft where it was like basically working, I'm pretty excited about that.
Excellent. Really cool. Yeah.
So Liz, I have one question. So how do you find the MIDI protocol as applied to woodwind instruments? Because you created for pianos, right?
Yeah, I'm gonna use CircuitPython. That's what I write most of my project with, and then basically it'll just be the note as it corresponds to the MIDI note. So the C on the recorder be the C in MIDI, so probably 60. So
okay, so no bending, no loudness, anything like this.
No, I think I'm gonna keep it pretty just in out for this, at least for this version, just to because there's already a lot of stuff going on.
Yeah, of course.
A lot of moving parts going on. Yeah.
Yeah.
Cool.
Do you actually play musical instruments, Liz? Are you musical, or is this?
That's actually how I got into electronics. Was by way of music, as I was a music tech major, so like recording and stuff in college, and I got worried that I wasn't learning enough. So I got into electronics that way. I'm making MIDI controllers, and I built a robot xylophone last year, and so things like that. And I've also, heading into my 30s, so I had to get into Eurorack. So that was something I started doing during the pandemic. So yeah, definitely music's a big thing that I do.
Cool.
Yeah, excellent. Okay, let's move on to, I'm going to put Simple Electronics out of his misery. I think he's a little bit nervous. So
Never.
Go for it.
Well, I had to actually bulldoze my entire workbench to fit this thing on. This is the biggest thing I've ever built. So I'm here to talk about this guy right here. So this, for those of you that don't suffer from the same problems we do up here in Canada, this is a snow speeder. So it's a 3-skied, remote-controlled RC vehicle that is supposed to be designed to go over snow and rough terrain and all this stuff. I actually, I modeled all the parts you see here in CAD. I printed all the parts on my my pokey little 3D printer and assembled it right on time for the last bit of snow to disappear. So there we go. This is Project Snow Speeder. I don't really know what to say about it aside from the fact that I overcomplicated the design just because I could. And yeah, this was like a test of my skill and patience. How she blows.
Yeah. You got a video on your channel of your first drive. Can you call it driving? Your first sledding with it, including a pretty spectacular crash.
Yeah. So actually, this is a project that represents like 2 or 3 projects altogether, because one was the design. I am a Fusion 360 newbie, so I actually had to design all of this from scratch. So this part is the part I started with, and it's also the one that I'm the least proud of. And I think this guy here was the final part. So I got a lot of skills along the way. Another thing is I designed, obviously, the RC snowspeeder itself. And the third thing is I actually put a lot more effort into the video. So I increased my my production skills, my camera skills, added some music and whatever. So I think it's actually 3 projects polished all up together.
Cool.
Nice.
Awesome.
What do you use for the motor control?
Yeah.
Oh.
I see you using these, I think.
Yeah, so over on this side here, I have, I'm an automotive technician by trade, so zip ties and I get along very well. So I have a 30 amp speed controller. These things are actually, these are standard Lego parts, basically. Anybody who does remote control airplanes or cars or whatever, these things are very standard, and they control these brushless motors. So this one here happens to be a Turnigy brand, which is a Hobby King is a Chinese reseller of RC parts. So that is controlling the brushless motor. Brushless motors is the standard brushless motor you can find on Amazon. I think the keyword is 2212 if you want to get one of those. And there's a radio receiver over here to capture my inputs, and my inputs come from just a standard RC remote control. Oops, can't really see. There we go. Just a standard RC remote control. This one here happens to be a 9XR, which I bought because it's part of a, it's actually spawned from an open source project to control remote control devices. So I think the open source project is T9X, I think is the project. I'm not sure. Something like that.
We have a question from Photochromax. Is a brushless ESC basically so you can control it like a servo?
Yeah, actually, it's the exact same. It takes the exact same signal, so it plugs into this receiver the same way you would plug in a servo to a Arduino, for example. They're all programmed to use the same kind of protocol, which is it's like the length of a pulse. It reads in milliseconds. But none of the electronics are mine on this, so it's it's very minimal on the electronic side. It's more on the maker side.
Awesome.
I love the design of the skis for it.
Yeah.
It looks really cool.
I'm actually pretty proud of that. Actually, thanks for bringing that up. So I have a full. So first of all, it's completely snapped together. So I've got these pins that I've designed in 3D printed, and they just sort of lift out. This is the mechanic in me, right? I want to be able to fix things. And then I had to add grooves to them because there's no steering up here. The steering is done up front here. So if you don't have these grooves to keep it going in a straight line, it'll just skid back and forth. So that was part of it. And on top of that, if you notice, all the angles are 45 degrees. So you can actually print this without supports, just flat on the bed like this.
Nice.
That's cool.
Cleaning supports is a pain.
How fast does it go? What's the kind of top speed?
I had to fudge it a little bit for the video because there's some design issues. But I think on a icy parking lot, it'd probably go about 50 kilometers an hour or so.
Wow.
Yeah. Unfortunately, it's too light for this suspension, so it just kind of hops and skips around if you have an uneven surface, which it was designed to take care of. So on a flat parking lot, it'll go fast, but in the video, it's probably topping out about 30 kilometers an hour, something like that.
Still quite fast.
Yeah, it's not bad.
Very cool.
Yeah. Are you going to make it capable of carrying a person, maybe a small person, like a child, strap your child on it and shoot it?
I would love to design something that obscene. I would absolutely love to do that, but safety wasn't a concern. I don't have any blade guards or anything, so if someone wants to lend me their child, sure, but I'm not making one just for this.
Maybe start with a pet rather than a child.
No, I care a lot about animals.
Make some thing in that direction for his kid. I'm not sure if I'm mixing him up, but like
No, I
some
think he
tank
made
kind
something for himself too, right? He had a full
Yeah,
tank
so
that
for
he was
himself.
singing.
Yeah,
Someone was saying
for
on
the
the
small
video.
and for the big chat.
Yeah, someone was saying on the video to send the files over to Ivan and see if he can print a life-size one. But I mean, hey, the files, as soon as I stop being lazy, they're all going to be on Thingiverse for everyone to modify as they want.
Okay, cool.
Awesome.
Yeah. I wouldn't mind having a go at printing one, although I've got no ice or snow anywhere here.
Would it
Well,
work on
actually,
sand?
You can do sand.
Yeah,
Sand.
it will work on sand. And actually, I have a solution for you because this summer, the next revision is to replace these skis with pontoons. So this will be a water-going device.
Ooh.
Okay.
You guys have water in Australia, right? Sometimes?
No.
You could always make it skid over like dropped resistors from the channel.
True.
That's true. I got plenty of that. Plenty of that. I'm still finding stuff on my carpet.
It'll have
Yep.
to be 0 ohms because if it's too resistant, it won't go.
Oh, very funny. What about hover? What about putting some blades at the bottom, giving it a bit of not full hover, but you know what I mean? Like, no,
You
forget it.
could. This thing actually produces about a kilo to 1.5 kilos of thrust. I didn't really measure it. So, and this thing only weighs something around 800 grams. So if I pointed this thing straight down, it would go up for sure. So you could incorporate, something on the side or something like that. But in Canada, if anything leaves the ground, remote control above 250 grams, you need a license for it.
Really?
Yes. Our drone laws are such.
How high though? Like, is there if it goes over a certain altitude? Or-
Anything over 250 grams that is considered a remote control aircraft, you need a license.
So even if it only goes up a meter, it's still
Still, you
Wow.
can't. Yeah,
that's crazy.
unfortunately. Yep, that's because people were flying, DJI Phantoms at the airports and shutting down flights.
Right.
And that's why you can't have nice things.
Exactly.
There's always someone spoils it for everyone else, right?
Yeah, always.
Cool.
Thankfully, like electric vehicles, like I could make this thing life size, and I don't think I would need a license to drive it. Just my regular driver's license would work for that. But as soon as it flies and it's over 250 grams, you need a license for that.
So what if it hits a ramp and then it's like briefly in air?
I just make sure the RCMP aren't watching.
Wow. Okay, that's really cool.
Thank you.
I think next up we're going to go Chris.
Sure. Yeah. So I feel like I haven't got anything anywhere near as cool to show, so I feel slightly upset now. That was brilliant. So I've been playing around with lots of audio stuff. So recently I've made a little walkie-talkie. So I've got a couple of walkie-talkies that I've made. So inside of these, I've actually used Sean's tiny Pico as the brains for it. So thanks, Sean. That was nice to get that and fit it in. So it's got a microphone and a speaker. So I'll see if it actually. I'll try powering it up and we'll see how much feedback we get. So let's see. Testing. So I hope that came across. But yeah, so there's a couple of walkie-talkies based on the ESP32. So I started off with those just using broadcast UDP to transport the audio, and then got it working using ESP now. So I was pretty pleased to actually work with ESP now because the packets are absolutely tiny. I think it's 250 bytes, so it's really probably pushing it a bit too hard. So that was a recent kind of interesting one. Yeah, and a question from Bitlooney. Yeah, I did. Well, did I solve the noise? Yes, I had some weird noise problems where I was picking up a lot of. I've seen it before with analog microphones where when the ESP is transmitting over Wi-Fi, there's a lot of noise on the power line. And with analog microphones, because the boards have really sensitive preamps, it tends to amplify that noise really massively. So you end up with, whenever you transmit over Wi-Fi, you get this sort of, especially if you're doing it periodically, and it's a really annoying sort of sound. And I was using I2S microphones on this version, and I've never seen that noise before. And then one of the viewers of my channel got in touch and said that he'd found sort of actual physical noise coming from devices. I think he's been in touch with you as well, Sean. And at first I was kind of, that doesn't sound possible, it seems very unlikely. And then I still can't tell if I started to imagine noise coming from the devices or if it really was noise coming from the device. Because I swear for a certain amount of time, I could put my ear really close and hear some kind of sound every time it transmits over Wi-Fi. And then it kind of disappeared. And I was still getting electronic noise. So in the end, I just built a simple sort of filter for the power supply. So you can see, let's see if I can show this. So here we've got an inductor and a capacitor, and hidden under here, there's another LDO regulator. So I'm kind of taking a feed from the battery and just really filtering it to get a nice clean power supply for the audio part of the system. So that kind of solves that problem. The noise, it's never going to be particularly clean, the signal, so ESP32s are pretty noisy anyway, and I'm not an analog engineer, so my circuits and PCBs are never that great when it comes to audio. So even when I've got a really quiet room and everything's perfect, I'm not using Wi-Fi, there's still a lot of noise on any audio stuff I do. So I've been doing some stuff with SD cards. Another viewer got in touch and was saying that he was really struggling trying to record audio to SD cards. So I've ended up soldering up a little SD card with some wires. I only found out you can do this after I've ordered a bunch of breakout boards, but apparently they're just SPI, so you can get these little SD card adapters and just solder them up with some wires and plug them in, and it actually works quite well. I mean, there is a bit of noise on that, but there's no Wi-Fi, so it's a lot better. So then I've also been playing around with visualizing audio. So I built a little board with it's a TT Go with a display, so it's doing a nice little spectrogram. So when you make any noise, it sort of shows you a nice pretty picture, and you can switch it into a nice sort of bar graph mode. So that's quite fun and enjoyable to watch. It's very nice. I mean, the colors, it's very hard to get the colors when you're filming it. It just kind of washes it out completely.
I get an idea though. It's cool.
It's incredible. But yeah, when you film it, it kind of looks kind of just like white bars flashing up and down. So that's been kind of fun. I've been using that to test my microphone boards as well. So I've been getting some little I2S microphones made up, and it's quite useful you get sort of 100 boards made up, and they're all paneled, and some of them don't work. So it's quite nice to test them before you send them out and just stick them on some headers and just hold them there and start whistling at it to see if it actually does anything. So that's been kind of fun. And then I've got a whole bunch of audio boards that I need to start actually investigating. So there's a ESP audio kit that has sort of codecs on it for doing encoding of audio. And there's one of these which I haven't even looked at yet, which I might use to update my DIY Alexa and make it more Alexa shaped because it's circular. So I can print a nice cylinder to stick that in and see how well that works.
I was actually looking at those boards last week.
Oh, really?
Yeah, and I almost hit the trigger to buy. I was going to buy all of them, but I want to wait for the new S3 versions of them.
Yeah, exactly. I mean, this one came. So this circular one, I was just chatting to a friend of mine, another maker up in Edinburgh, and I was just saying that I'd got one of these audio boards, but this one uses a different codec from the ADF, so all the expressive code expects on which codec they use in all their boards. But this one uses is it an AC101, maybe? Something like that. So I was mentioning that to him, and he said, I've got one of those boards upstairs, and just came down and gave me one of these. So I was kind of sort of,
nice.
I might need to do a video on this now because you've given me it. So that's mostly audio stuff. And then today I was trying to resurrect one of my older projects, which is this kind of thing with, it's about 5 meters of addressable LEDs, and it was working really nicely, and then suddenly it just stopped. And I suspect it might be due to the absolutely appalling wiring going on. That's it's not great. So that needs a bit of a rebuild at some point. And then the other thing that I've been doing, I showed you guys this robot earlier. So this is more of a kind of software thing where they built this robot that walks around and has an app that goes with it. And I'm
so cute.
Trying to help them drive it via Scratch. So they've got an app and they're embedding the Scratch environment in the app, and I'm helping them with a bit of software. Actually, the same guy who gave me the audio board has been writing most of their firmware, so it's been really interesting. And that's an ESP based device. You can actually see. You can't really see much of his brains because it's hidden by a battery. But they've done some really interesting stuff with servos. So the servos are kind of intelligent servos. You can send them trajectories and they'll just run it by themselves. So that's been me for the past kind of making time. That's mostly audio stuff. I seem to have got into a bit of a niche where doing I2S audio seems to be my thing, which has been a learning experience. I spent a year messing around with audio, and I was looking at my original code from a year ago and looking at my code now. And after lots and lots of input from other people on YouTube of why have you done it like that and what were you thinking when you did that, I think now I finally understand how to do it properly. So I'm now going to go back to all my other projects and redo them all and try and fix them so they're doing it the right way. I'll get back to that at some point.
Yeah, it's all a journey. It's all learning.
It is. It's really interesting.
Electron Ash. I should put that up on the screen. But
oh yeah, lasers. Oh, I completely forgot about the lasers. Yeah, my laser projected asteroid. Well, that's currently stored in a box now because it was taking up a bit too much space. But that was a fun project. So that's, if anyone remembers asteroids from the arcade times. So I got hold of. I can't remember why the idea came to me, but it was just to sort of. I think I was thinking about lasers, and I was thinking about building some of these laser galvos, but from scratch, because I've seen some people do it using old hard drives, and I've got a drawer full of hard drives that I've slowly collected over the years. I keep hoping that maybe there's a stash of bitcoins on one of them, but I haven't found it yet. But so I thought I'd take one apart and use it to make some laser galvos, and then realise that actually you can buy them on eBay for sort of £80. So I thought I'd just buy some laser galvos, and then I thought I can do some laser projection stuff, but wouldn't it be fun to build asteroids on top of it? So I built a little games console with a speaker inside and driver boards. We should try and bring it down. I'll bring it down when the next person's on. I'll bring it down. I can show it after this and try and do that out of the boxes thing. Yeah, lasers and asteroids. That was great fun. So.
Yeah, that was the project that got me into your channel. Watching that journey. Yeah.
Yeah, I can tell about it.
Yeah.
I think one project drives out the next project. It's kind of this long list of projects, and they kind of come on this conveyor belt of things, and then it kind of pushes them out of your head. So
yeah.
All my range is getting smaller and smaller. I can only do one thing at a time. That might be closer to the truth. Yeah.
I don't think there's any maker that just does one thing at a time.
No, I did tidy my desk before coming on the show because I thought it was embarrassing. It's normally a packet of electronics and junk.
Sure. Excellent. Okay, I think it's time for deshipu.
Okay, hi, I'm deshipu. I'm a Python programmer mostly, and after hours, to escape from the complex programming, I do simple programming with Circuit Python and electronics. And today I wanted to show you some of the things I started with initially, like 8 years ago. And so I got into this whole electronics thing because I wanted to build a walking robot, a spider robot specifically. And I thought, how complex can this be, right? You just need servos and you some way to program the servos, and off you go, right? So this is actually the second one I built. The first one was much larger. And that's when I learned that the smaller the robot is, the easier it is to build. Because you can use cheaper parts, you can use plastic instead of metal, for instance. And when it breaks, it's easier to fix. Like this robot actually did fall from the table several times and didn't break. And if you make anything bigger, if it falls, it's in pieces. So start with small. Start with small robots. So this one actually, I really wanted to use Python. And at the time there was no MicroPython yet. that it is that far ago. So it actually has a Bluetooth transmitter, like the serial over Bluetooth thing, and I ran it with Python running on my computer and transmitting the servo commands over Bluetooth. I no longer can do that. Now it stopped working, but I keep it for sentimental value. And this is also when I started to put hats on robots, because hats really add,
Fair.
I think so, at least they add some character to them.
I'm so happy.
Of course, you need to,
Absolutely.
because if you don't put googly eyes on your robots, then people will take any symmetrical feature on the robot that is accidental and treat that as eyes. And then you get unpredictable results from that. So better put your own eyes on this. So there is no
That's a
no confusion.
reasoning for googly eyes.
Right. So the second one, I went even smaller. This one actually works. I can switch it on.
This is cute. I love it.
Yeah, and I have a pilot that I can use to control it.
Oh, wow.
That's awesome.
This is too cute.
So the servo sounds makes it sound like it's talking.
Yeah, that's brilliant.
Yeah, those are very small servos. You can actually see that on one of the legs, the servo is breaking, so it has like this shaking motion.
Oh no.
What
The
servos
problem is
though?
those servos are really for really tiny airplanes, and they are not supposed to be used like under stress that much, so they wear out. So yeah, this is a normal like Pro Mini, yeah, Arduino Pro Mini in there, and just some Arduino code. Not I was learning Arduino back then, but then I figured out, okay, why not put Linux on it? So at the time there was this tiny little Linux board that actually used a chip from Wi-Fi router. That's an ancient MIPS chip, and it had the OpenWRT Linux running on it. So I used that and made this robot. It's the same mechanically. It's the same as that one, but has a little bit more electronics inside. And since that board is basically 1 inch by 1 inch, so it was really nice at the time. It takes like 20 minutes to flash it, though, because OpenWRT. And I also put a module from an old laptop. This is a camera module. So it actually streams video from this tiny Linux board. And you can kind of control it through the browser, so you can explore under your bed and things like that. So that's quite nice. At the moment, it doesn't work anymore because Linux on those small devices wasn't really very reliable at the time. So that's very well. So then I wanted to still use the small servos, but do something simpler. This is only 4 servos. And this one is not remote controlled. It's just like the default walking thing that all the Arduino robots use, except it has this thing where it will avoid obstacles because it has an infrared sensor.
That's very cool.
Yeah.
I like that.
Can you just give us a close up of the face with the moustache?
Right. Yeah.
Got some swagger going.
That is so cool.
Yeah, you can actually the camera picks up the infrared LED.
Yeah.
You can
Like
see
a
the
monocle.
Brilliant.
Looks like evil mastermind.
Yeah, actually, with this one eye shining, it looks like it's a monocle or something.
Yeah.
That's really cool.
Right.
Awesome.
So that's another tiny one. And then I started to do it seriously. And I made this robot called Tote. So it looks like this. The thing is, I had no 3D printer and I had no access to laser cutter. So I wanted it to be possible to easily build robots without access to all those special tools. So I made a robot that basically is just this PCB to which you screw using the same screws you get with the servos. You screw the plastic horns you get with the servos. And the legs themselves are also made out of those plastic horns. So you don't need, you just get this PCB. The idea was to sell it on Tindy or whatever. I don't remember if Tindy was there back then, but sell it wherever and just let people buy the servos, and that gives you everything you need for that robot. And of course, the first version I made uses Arduino as well, the Arduino Pro Micro, because that Pro Mini, because that was the cheapest board you could get at that moment, and Arduino easy to program. So I don't have anymore the unmodified, the original version, but this is the same thing inside, except it has this case made out of children's block. This is basically plastic block for children that, and then it's painted with some metallic paint. But yeah, I can make it. So it has the same control thing with that. Yeah, you can see this leg is shaking. I think I can. Yeah, I can switch the eyes on. Oh, and it has a piezo speaker inside, so it does beeps and things like that. So yeah, this one is called Tote, T-O-T-E, and it's actually like all the things you need for it are published on toad.rtfd.io. So you can build one like this yourself. Yeah, it can also run like 2 legs at a time.
There's something mesmerizing about watching these things move.
Yeah, you can see this leg is not very healthy right now. So that's the problem when using cheap servos. They wear out rather quickly, but until they do, you have some fun. Yeah, sorry.
There we go.
Yeah, actually, I have a better one. Yeah. Yeah. And then MicroPython appeared, and shortly after that appeared CircuitPython. So I made one that uses Adafruit's feather board. This one has a, which one is it? The M0, yeah, the M0 feather. And because it has shields, so you can stack on top a shield with sensors and speaker and whatever. So that's what I did. So you can basically build like a tower of different expansions, and of course a hat on top. So this one uses very strange servos that I found. They're a little bit smaller than the regular 9-gram servos that I usually use. So this robot is a bit shorter than others. And I used some RGB LEDs for the eyes, because this one is supposed to be like a crab. Let me. Yeah, so this one is it's supposed to have some logic. It tries to go forward as long as there is nothing in front of it. As soon as there is anything, it will try to determine if this thing moves or not. If it doesn't move, then it will try to go around it, and if it does move, then it will just wait for it to go away. And if you put something too close to it, it will go backwards. So you can make it go backwards. Yeah, and depending on the state it's in, it uses the RGB LEDs to tell you. You can see it's not working very well with the electric lighting in here, because it messes. The distance sensor is infrared and it messes up with the electric lighting, so it's not very reliable. I plan to one day build a similar one using the time of flight sensor, which is much better for this. But time, yeah. And then I started to think, okay, those robots are nice, but nobody is going to buy 12 servos, even if they are like $1.50, just to build a toy like this. So I started to look into making them even cheaper. And so I thought, what about, so do I need 12 servos to have a proper walking? And turns out that if you do like a mammal configuration, so with legs straight down instead of sideways like in a spider, you can get away with just 8 servos, as long as you don't plan to turn. Or if you are okay, if it turns like a tank, skipping. So
it's kind of important, isn't it?
As a prototype, you can see it's also not great at the moment, but generally it works. So I started to work a little bit more on that. And at one point I did a laser cut My Little Pony, like this one. And once I got this, I figured out, oh, maybe we could turn it into a robot somehow. So I made another one. And that's the horrible abomination that you get. Those are the same tiny servos I used in those robots. And it uses this mammal configuration. So yeah.
Wow.
The thing is, I never actually took the time to program it. So it's not working yet.
That's a shame.
Yeah. But My Little Pony has a robot. Why not? And then I thought, okay, I can make it more compact. I can use the cheap servos, and this was a prototype still using the PCB from the other robots. You can see the holes for the horns in here. And it looks like this. Also using 8 servos, but it's in a more like spidery configuration. So I like this better because I really love arachnids and stuff like that. So I made 2 more proper versions. I still didn't decide which one I want to use. One has only very minimal PCB, like it's just the size of basically Adafruit feather, with place for the servos and with just a small header in here for the distance sensor if you want one. And the other one is a much bigger PCB, it's this size. But apart from driving the servos, it also acts as a feather itself. So you have place where you can plug feather wings into it. So you can use, for instance, one with a display to give the robot a face or of some sort. And I can right now. This is not yet working. It has only test of the servo motion. But I have tested the walking with the previous prototype, and I'm confident I can make it walk at least straight. Not turning is going to be interesting. But yeah, and that's probably the cheapest four-legged walking robot you can build. So that's what I'm working on right now, software for them, basically. And it's CircuitPython, so you just plug it in, get a USB drive, and program them. So that's easy enough. Also, because there is only 8 servos, I can use the built-in PWM from the SAMD21, because it can drive up to 10 PWM channels, at least with CircuitPython. So with the 12 servo one, I had to use a separate chip for driving the servos. This is basically this is, by the way, a PCB for this version of the robot, because I had this idea. Okay, you don't have a 3D printer, you don't have a laser cutter, but you are ordering a PCB anyways. So why not put all the mechanical components you need on that PCB and just break it off? And as a bonus, you can also even put those are SD card switches. So switches that are normally used to see if an SD card is connected or not. So they are very light. So they are very super easy to press. So I use them as the ground sensors. So when your robot is about to fall off your desk, you can detect that there is no ground in there and stop the leg and stop the robot from falling down. So that's a nice way to use. Later, you see, I switched to laser cut.
Daggers. You need dagger legs to stab you, right?
Right. So the thing is, right now, it's so easy to get something laser cut. It doesn't make sense to design around that. And also, I needed those brackets for the servos to keep the servos connected together. And doing this with PCB would have been a huge pain. So I decided not to do it that way. Here, this one is even more interesting because it has also the inside, like the whole thing is laser cut, and the PCB is just added on top of that. So the PCB is not even part of the mechanical construction anymore.
Is the software, how different is the software for each robot? Is it the same kind of software, or do you have to rewrite it each time?
So I started with Arduino. So obviously at some point I had to rewrite it to CircuitPython. And that's why the most feature-full, like the most reliable one is still this the last one that used Arduino. I even got like 2 different gates in it, like the crawl and the trot. And I never got to this level of sophistication. I never got to this level of sophistication with Python, even though Python is much faster to develop and much easier.
Yeah.
Probably because it was too easy at this point for me, and it's not exciting anymore. I did it once. I know I can do it, so it's not that you don't have that much motivation anymore. But I will get there eventually. So yeah, I had to rewrite it to Python, to MicroPython at some point, then to CircuitPython, which was a small change. So with each new robot, I use a slightly different way to drive the servos. So that part I usually need to rewrite. The latest ones just use the built-in PWM of the chip. The previous ones used an I2C chip for PWM and so on, but that's just one class you have to rewrite, so that's not that complex. And the gate itself, it's not, because I've seen a lot of robots like that made with just pre-programmed positions, like this bit something thing out there. But they just used like predefined positions between which they switch.
Yeah.
And here I'm generating the gate dynamically. I mean, it's not a closed loop or anything like that because it doesn't really have any sensors. But it's generating, like for instance, if you are turning, the exact positions where it places the legs are computed live, not predefined. That makes some things harder because you need all this logic to define where you want the leg, but it makes also a lot of stuff much easier because you can at the same time turn, go forward, and strafe a little bit to the side, for instance, and the robot is like, okay, you just put this in the variables and it does it. I'm working also on this a little bit more advanced controller for it, but because this is a great way to add a lot of buttons to your project. You just buy like a integrated infrared sensor, which looks like this. It takes one pin on your microcontroller, and you get access to all those buttons, or you can use a bigger remote and have even more buttons. So this is a great way of cheaply adding a remote control to your project. Problem is it's not very fast or very reliable. So sometimes you have to press the button several times, or But for a toy robot like this works very well. Yeah, that's
Wow.
all. Thank you.
That's a stack of robots. Over how many years, deshipu?
I think it's around 8. No, wait. I'm 6 years in Switzerland, and I started before I moved to Switzerland. So it's about 6-7 years.
Nice.
Cool.
But not all the time, of course.
It's cool to know different mechanisms you have going, because Nye and I've discussed like trying to do a robot at some point, and we always kind of get stuck on the mechanism. So it's cool to see.
Yeah. So the thing, I shouldn't be doing this. I'm just putting everything on the the servos at the bearings. I don't use any bearings. I should have a support on the other side of the servo as well, and so on. Because those robots are so light, it doesn't matter in this case. Again, start small, it's easier this way. But it's not like a kosher way to do it, because you get this sideways force on them, and that also makes the servos wear out faster and so on. So I'm cheating here, basically. Mechanically, I'm just reusing the mechanism of the servo for all the joints.
I think we all.
You reminded me of like 6 years ago. I did this very similar style, crappy.
Yeah, that's sweet.
It walks. It's very bad. I had a LiPo battery on top of it at some point. I couldn't get it to work just now, but
yeah,
I love your stuff.
I also have the same problem I always have with the cables. What to do with the cables?
Yeah,
because they are way too long.
I tried it like you used it to
but it's
as a mechanical.
Shame to cut them. So
I think I'll stick to wheels. They seem a bit easier than walking. That's my attempt at robot.
And I also actually had a top hat for this, but it's gone. I couldn't find it.
Cool.
But yeah, love it.
You'll find the motion of skis a lot easier as well.
If you make a skiing robot,
that's pretty cool.
This motion not with a fan, but by moving the skis, you will find it's not that easy.
You just need this motion. You just need to be able to get two servos.
That's true. That's very true.
It's actually, I want to make a four-legged robot at some point that is technically four-legged, but it's actually like a gorilla. So it's a two-legged gorilla that's just using hands to also walk. Because you can use the same algorithm as for four-legged walking, but it looks like a two-legged robot.
Okay.
That would be cool.
Then you can make it climb, right? You can
Right.
yeah.
You know, a gorilla or a like werewolf. Werewolf would be cool.
Have you ever looked at brushless motors?
So there are two problems with using anything but the cheapest servos you have. They're expensive, relatively speaking. You need 12 of them.
Yeah,
So you know you need a transmission of some kind, and you need a controller for them, and that gets expensive super fast. I don't know if you watch the
it's
YouTube
I
channel.
think the same kind of kit that Simple Electronics is using. I found these for like €2, like with the ESC and the motor. And I've never really seen people do much like robotics with them, but I think they're
Yeah, but you
That's
can
exactly it.
control the position of the motor with this, right?
Are you like so
You
there
still need
are
encoder
ways to do
to
this
control
sensorless? So you can like turn them into like that's what you call it, like industrial servos, or like essentially these, but with a sensor. And there are like smart ways to do this without like a dedicated sensor, like with EMF feedback stuff. I am not too deep into this, but there are some
Right.
yeah
Yeah,
interesting.
it's way more advanced than I'm ready for right
Yeah,
now.
that's fair.
I know some people who do stuff like this. There is recently a very nice robot on hackaday.io called Wolfie. That is made by a Polish guy, but he first built a CNC machine to cut out the aluminum parts for it. So, you know, not this level of hobby as I have.
Cool.
Okay, thank you.
Okay. Well, I guess that just leaves me, and I've got very unstellar things to talk about then compared to all of that. I've been mainly doing software-related stuff over the last little while. I finally moved Sam into my garage, although I'll put a video together about it soon. I've got all my racks in there finally, but they're still unpopulated. I'm still tinkering away. I just purchased one of these the other day. These are the new version of the Respeaker microphone from Seed, but it's their USB version now. So it's literally just you plug it in and it's a directional microphone. And I believe it's got a speaker as well, where you don't program it like you do with their original Respeaker boards. So you can plug into any computer and it just becomes a directional mic. And since I put that on Sam, the microphone pickup quality has been exceptional. I can actually stand in my garage, like when Sam's on my desk here, I can stand in my garage and talk to Sam just with my normal voice, and this thing picks it up, and it's incredible. I wish I would have got one of these a long time ago, because I was really struggling with trying to find a decent microphone that I could use. Ended up using a webcam, my Logitech Webcam for a while, but it's kind of directional. Interestingly, I had to turn off all of the, so this has got 4 mics in it, but if I leave it on using all 4, I get this really weird echo that the Raspberry Pi for some reason can't break down my my voice properly. But so I put it onto a single mic, but it's still directional, and yeah, the clarity is fantastic. So I've got Sam sitting on my desk still here, and I can use it from in the garage. Anyway, that's been pretty cool, and the rest of my time has been spent finally getting my tiny S2s ready. So I am about to ship these. So this is the first time making a board that's in my tiny Pico format. but it's not a Tiny Pico. It's using the ESP32S2 chip with built-in flash and RAM, but it's still pin compatible. So it'll work with all of my Tiny Pico shields and any add-on boards.
Big?
Oh yeah, I should go big. Sorry.
No, it's all good.
There we go. So, except it's not going to focus. So this will work with any of the add-on boards for the Tiny Pico, but it's a Tiny S2. And yeah, this has been an interesting journey to get this going because the chips are brand new, and getting them from Espressive was a bit of a struggle. Had a lot of issues with the PCBs from JLC PCB, but I finally got everything here and started production. These are going to get stocked Adafruit, Pomeroni on Amazon, US and EU, and of course from me. And I was going to launch them today on the stream, but I'm going to have to wait. I'm still got a few things to tidy up. But I've made a version of MicroPython. So these ship with CircuitPython on them, but I've also made a version, an early version of MicroPython that I've got on GitHub that I'll release the next couple of days. And Espressive have finally now merged their S2 branch into their master branch, although they've still got a lot of work to do on it. So hopefully there'll be a lot more Arduino support for the S2 soon as well. So this is really cool, but it's just another board in my production line, which is getting quite extensive. So I've been making those and packing bags, which is so much fun. Spending my days manufacturing and then my nights labeling and packing bags. And when you do that and then you go to bed, you have really weird dreams of stickers and labels. And I think one night I woke up and because I had this dream, I had stickers stuck all to my hands and I couldn't use my fingers. Yeah. So yeah, that's been pretty exciting. And through this whole time, I've got my new Prusa sitting on the couch, and I promised myself I wouldn't open it until I got this done. And I stuck a Seon "Do Not Touch" on there because
that's not for yourself. Okay, I see.
To remind myself because I know once I pull that apart and start, then I'll start rearranging my office to where it's going to go and whatever. It's got to. I got the MMU 2S, whatever it is, the multi-color thing with it. And I know once I start playing with that, I'll lose like a week of 3D printing multicolor stuff. So I wanted to get my S2 ready to go first. But yeah, like my time's just been basically juggling between the two, between Sam and ramping production up on the S2. Dodging pretty unexciting.
I have a question for you, if you don't mind.
Sorry.
Oh, yeah. So go ahead.
No, go ahead.
Okay, so if a customer finds himself on your website and deciding between the Tiny Pico and the Pico S2, what would you recommend the S2 for, and what would you recommend the Pico for?
Yeah, it's I'm started working on a little like a what are they called? A comparison chart of the two boards that I'm going to put on the Tiny S2 page on my website, which is live, by the way, but you can't buy them yet. It's just a wait list. Just to kind of explain the differences between them, because there's a bit of a crossover. But yeah, it's hard to kind of push people in a direction. I mean, one of the key things with the Tiny S2 is CircuitPython. It's you can't run CircuitPython on any of the previous ESP32 chips. And there's just a stack of people in the CircuitPython community that really want to play with ESP32s. And, my Tiny Pico footprint and format has become a very popular board. So, I don't know. I mean, if you need Bluetooth, you got to go Tiny Pico. If you need multi-core, you need to go Tiny Pico. If you want to play with CircuitPython, you need to go Tiny S2. The Tiny S2 is going to be a little bit cheaper than the Tiny Pico. So if you're budget constrained, maybe the Tiny S2. I don't know. It's an interesting one. Like in the back of my mind, I'm thinking to myself, you know, I don't want to. It's not a replacement for the Tiny Pico, and it's got, I guess, a slightly different use case. But there's a lot of crossover as well. I mean, you need to get down to the nitty gritty of the differences on the chip, because you know the S2 has got a lot less stuff in it than the regular ESP32. You know, it's only got like one I2S peripheral instead of two. It's got, you know, the single core. It's got less memory, although this has got 2 meg of PS RAM. Tiny Pico's got 4 meg of PS RAM. I don't know. Yeah.
Are you planning for having an S3 version once that is available?
Yeah. I've already got 3 boards designed for the S3. I've got my Pro S3 is ready to go. My Feather S3 is ready to go. And I have a Tiny S3, which I guess will replace the Tiny Pico eventually, because it'll have everything the Tiny Pico's got plus more. But the chip I need for the Tiny S3 is 5, 6, 8 months away at least. Espressif generally release their versions that have PS RAM and flash much later after their first lot. But yeah, the S3 is not even gone in production yet. It's still a couple of months away from going into production. So I've got my stuff ready, but, you know, and, you know, there might not be production in 2 months with the way everything's going. Like right now, chips are available from Espressif, but their lead time's getting longer and longer. You know, I bought up a stack of components over the last month to make sure that I've got enough stuff here to keep building boards for the time being. But I've probably only got enough components for maybe 2 or 3 months. And at this stage, it looks like this shortage is going to be going for, you know, 6 months, 9 months. No one really knows. So
yeah, probably the whole year.
Yeah, I'm most likely going to run out of stuff and not be able to build things, you know, at some point. But yeah, I'm preparing for. I mean, this 3 is kind of exciting. They just announced their ESP32 C6 the other day, which is kind of weird because the C3 isn't actually available yet. Like it is, but it's not. You can't really buy them. So they've already superseded one of their chips with a new one, with a new announcement. Like, I'm not sure who's going to run out and buy C3s right now, knowing that the C6 is coming. Yeah, I don't know. It'd be interesting. I mean, there might be an S4 announced before I've even got my hands on an S3. I don't know.
Yeah, going really fast.
Yeah, they're going super fast, and not quite sure.
Like they aren't that affected from, I feel, from like the whole chip shortage. At least not as hard as like STM or microchip and stuff like that.
They're not at the moment, but like they make millions of chips, right? I mean, the maker market for them is minuscule. Like it's not even, you know, it's probably 0.1% of their thing. So they've been making and stocking up chips for ages, but my understanding is their lead times are getting longer. I'm kind of lucky. Like I joke around a lot that I buy my stock from their petty cash. You know, do you ever know the term petty cash? Like, you know, normally a company, like if you need to go buy milk, you know, that they go to this little thing and they take out some money and give it to you to go buy milk for your company, right? You know, you don't have to go to the accountant and ask them for money. So especially if we've got like a stash of reels that they use for emergency situations, and that's where I buy my stock from. You know what I mean? Like I go through, because I buy such small quantities compared to some of their other, you know, people. But yeah, I think at some stage they're going to get hit with this shortage as well. So yeah,
that sounds like maybe yeah, smaller customers like you have it better in that case, because it don't.
I think so.
Chips.
I think so. Like I can still buy right now. Like my lead times are still 0. You know, like if I order and pay today, they'll ship it tomorrow, type thing.
Yeah.
But yeah, like I've only got 1,000 of these S2 chips that I'm using my Tiny S2, and production was supposed to start at the end of last month for them. So I could get more, but it didn't, and now it might not be starting until the end of this month. So, you know, I might run out of these and then not be able to make them again. I don't know. It's interesting times ahead from a manufacturing point of view.
Yeah,
I don't know what's going to happen. Like I know the other day I bought all of the Sambi 21s that Mauser had in stock, which was like 51. Like of the ones I needed, they had 51 left worldwide, and I bought all 51. That was just so I can keep making reflow masters right now. But I can't get my thermocouple chips anymore. I've got like 100 here, and that's it. So, I mean, lead times are 50-something weeks now for my thermocouple ICs. So once I run out of those, you know,
I had some couple like products in the line, and I just like I won't make these this year because I need the Sambi 21 for that, and it's just I probably can't get that. So I just won't do certain things. So.
Like it's a vicious circle. Like it's companies stockpiling chips that's making the situation worse. Yeah. But I'm stockpiling chips.
It's like the toilet paper situation of the chip industry.
Yeah. So like the other day, I've got a couple of boards that I was hoping to be ready in time for MakerCast, but they're not. I'll have them probably tomorrow for the 2 new things that I've designed, and they both use tiny 1606s on them. And although there is stock right now of that particular model, there's no 1616s or anything like the bigger ones. Like I don't even know if the 1606 is going to work for these boards because I haven't got the prototypes yet, right? And I don't know if I've got enough memory inside them, but I can't go to the bigger version because there isn't any stock. So I just bought 250 of these ones and hoping that they work, because if they do, then I can ship this product, and if they don't, then I can't. But I can't buy replacement chips anyway. So yeah, like Mark Olsen just saying that the STM32 chips the zero, like you just can't get them anywhere. So
and if you can get them, they cost like 5 times.
Oh, that's the other thing. Like everyone's just hiking their prices. Interestingly, Mauser and DigiKey haven't been, but places like LCSC, like some of their prices are like 5 times what they were last time I purchased, and there's no need for them to be upping the price like that. But supply and demand, apparently. So
yeah, especially if the stock is in China, there's so much more worth for like some companies. You pay quite a lot of money for like the import from all the US manufacturers. So
right.
Chinese stock is quite valuable.
Yeah. But even the Asian brand stuff, like the prices have been going up a lot. Like PSRAM, my PSRAM, like it doubled in price over the last 2 months or so. Yeah, it definitely makes things interesting. Like I'm trying to keep all my prices the same and not lift them, but it's getting really, really tight. And at some point, I have to decide if I'm going to lift my prices or just stop selling until prices come back down again. So, yeah, but that's been my little while. And something else that's exciting is I'm all ESD now. I have new ESD mats, and I've got everything else. So even though ESD doesn't exist, even though it doesn't exist, no, it does. It does. Anyway, I've taken the leap and I've decked my desks out with ESD mats. So that's pretty cool.
Nice.
Okay, well, that's me.
Awesome.
Told you it was after everyone else's
Well,
showcase. Mine was uneventful.
Well, new board's exciting.
Yeah, new boards, always good.
Yep.
I think it's in like what I forgot to go into that earlier, but like I find it interesting how like CircuitPython is like kind of like Python in general and hardware is like kind of ramping up in terms of like being used for products. And I'm kind of sad that Stargirl couldn't make it today, but because she's also using Python not only for like the prototyping parts or like as the like user language, but for like the firmware as well now. And that I find really exciting. Like it's also like a cool development. That's kind of happening. To see,
like Python's great on microcontrollers. There's still a lot of pushback from people, purists, I guess.
The graybeards hate it probably still.
Yeah. I mean, at the end of the day, if you need really performant stuff on your microcontroller, then you need to go, C++. But if you don't, or if you can work with a hybrid, because both, CircuitPython and MicroPython can use C modules, right? You can write in C for really performant, critical stuff, and the rest of the stuff you can just write in Python, and it makes it so much easier.
It's even
Sure.
better than that. You can embed function in your Python code that are written in assembly.
That's right, or even in assembly. I don't know if CircuitPython can do the assembly stuff.
It can. It
can,
does
right?
the same thing as MicroPython. So you just write your function in assembly. That's the most optimized thing you can do. And you don't need to compile it into your firmware then. It's in
you write it inline. Yeah, absolutely. Yeah.
So it's the best you can get.
Yep. Yeah, I'm really excited that Python's taken off so much.
What's the difference? Maybe a naive question. What's the difference between MicroPython and CircuitPython? What's the sort of, is there
Still the API. So
Yeah.
they wanted to do some things different. Like Adafruit wanted to work on MicroPython, and they wanted to find, they wanted to support 7021, for example, which is a very low power, low cost chip.
right?
And they were only supporting higher end STM32 chips, and for that they had to do some larger changes, and they wanted to gear the whole API, like the programming API, to something more user friendly and very consistent.
Mhm.
And that was just different design goals. So they forked MicroPython, and it's still based on MicroPython. They just have a different programming interface. So like the function calls a bit different. Everything is a bit more consistent between ports for different microcontrollers.
Yeah. It's more accessible and more consistent, but at the trade-off where you don't get access to all of the hardware and peripherals. And so it's a different target market. I mean, Adafruit are very, very, how do I put it? Really understand their marketplace really well. And it's definitely targeted to beginners, and entry level is the wrong word, but you know what I mean, to accessibility, like, that anyone can just pick up a device, plug it in and start using it, right? Where working with MicroPython can be, like it's painful to, to get code onto your device and debug stuff. You don't get a USB interface, you need to be, using some type of serial terminal to push your code onto there and then to connect to it to see what's happening. But MicroPython gives you access to all of the peripherals on an MCU, but also not necessarily the same across MCUs, right? The API changes, which is something that they're working on. They're trying to make things more uniform, where Adafruit recognized that they needed to keep everything uniform from the start to not confuse people. It's a shame that there's two different versions, but there needs to be, because it's two different purposes, I think.
I also find that stability is a very important thing. So in CircuitPython, whenever you make a board that is compatible with CircuitPython, they actually encourage you to commit it into the main repository, so that they can, whenever they change anything and it breaks your board, they can immediately see it and fix it. And whenever there is an API change, it's a big deal, and they really make an effort to go through all the libraries and fix them in the libraries as well, and so on. With MicroPython, you can get catastrophic changes from version to version, and nobody cares if your board still works or not.
That's a bit strange. It's not that nobody.
That's not my experience. It's probably much exaggerated, and it's from a few years ago. It probably improved, but that's what pushed me away from MicroPython and towards CircuitPython. Once you write something in CircuitPython, it will work.
Yeah. I mean, to be fair, I mean, Adafruit, they pay for people to work on CircuitPython, right? That like full-time people, and there are also lots of contributors who volunteer their time as well, right? So there's a whole business around CircuitPython, where with MicroPython it's pretty much all volunteer work.
I think I forgot his name, the main maintainer. I think his main income is for doing MicroPython ports for commercial products and stuff like that.
Yeah, Damien. Yeah, well, that's his business, right? I mean, the reason STM32 is so focused with MicroPython is because his business is around STM32. stuff and products, and so that gets a lot more love than other things do because he needs to feed his family, right? But that also then means that other ports don't get as much attention. The CircuitPython ecosystem with libraries and stuff is also way better. You know, Adafruit are committed to make sure that they don't release any hardware that doesn't have libraries and drivers for CircuitPython and Arduino, right? Where it's really lacking on the MicroPython side. You know, it's a lot spread out further, and it's kind of hard to find drivers and libraries sometimes, and you know.
And sometimes when you get a driver for instance ESP32, it won't work on a STM32.
Yeah.
Or the other way around.
Sure. Yeah.
Like
that. So
one
sometimes
more
you
I
have
forgot
to make fixes.
Mention that earlier. But,
sorry.
I think it's not very well known, but they have Blinker, which is a compatibility layer for Linux system on chips, so you can use all CircuitPython drivers on Linux without any changes, just works. And that I think is amazing, and more people should use that because it's fantastic. Like I have these demo or quick boards, a bunch of them, and I hooked them up all to my Pioneer, and it just works, you know. And it took me like 5 minutes to like get a bunch of sensors working, and you don't have this like, you need to like find a new platform. You like, there was always this discrepancy between like the big Linux chips and like the microcontrollers, and they kind of bridging that with CircuitPython, which is I think really exciting.
Yeah, all my
test jigs go from microcontroller to Linux and use the same code. Yeah,
all my test jigs are using Blinker, and I'm using, you know, like they've all got MCP 23017 muxes on there and stuff, and it's all just CircuitPython libraries that I'm using to drive all that, and with the screens and everything else. It definitely made the ability for me to set up test jigs really easy. So yeah, like Adafruit are doing a great job from that respect, and they're doing a great job promoting Python on microcontrollers. You know, but they, again, like on my Reflow Master Pro, I'm using MicroPython because I need to be using some of the like peripheral stuff on the ESP32 that, firstly, there's no CircuitPython for that ESP32, but even if there was, some of the stuff that I'm using is abstracted away. But it'll get there. Like, you know, I'm using a lot of async IO that's coming for CircuitPython. The differences are getting less, but the philosophy behind them is diverged. So yeah, but there's space for both. It's fine. Like, you know, you use whatever platform that works for you. That, you know.
Yeah, I mean, things like interrupts, for example, they, I think, still are not present in CircuitPython. So yeah, if you want to do some more advanced things, you still better off with MicroPython.
And they won't be. Because they don't feel they can explain interrupts to people enough.
I thought there was work for that going on.
So they will have different ways of doing asynchronous things, like the async keyword and async functions and stuff like that.
Yeah, I saw that. I thought that would support it at some point, at least, interrupts. It would be sad if they don't do that.
No, Scott's already said he doesn't really. Scott said that he can't think of any use for an interrupt, like anything where someone would need one, where they couldn't use CircuitPython in a different way to avoid needing an interrupt. So he doesn't see why at the moment. I think that was
maybe I should give him all my reasons for that because I haven't done.
But interrupts are really difficult, right? They are quite difficult, and in Python they're even worse than in Arduino because they're people have an expectation that when an interrupt gets fired and the function that gets called from your interrupt, like that function is actually isolated, and people try to put code or access variables inside that from the rest of their app, and it doesn't work, right? And then it's confusing for people why things don't work. Like interrupts are quite tricky, I think. Yeah, I'm not sure.
At least for wake up, that would be handy. Like, I thought that maybe they at least added. So, like, if you go to
there's already wake up support in CircuitPython for, I think, ESP32S2.
Yeah.
And they did it with something like interrupts. They call it alarms.
Right,
But
that was keyword.
You just specify what is supposed to happen when this thing happens. You don't put code in your function, basically.
But that's half the way there. I mean, that's the main use, I would say, for many interrupts.
Yeah, exactly. So they basically try to do the same things as you do with interrupts in simpler ways.
Well, that's good then, though. I mean, as long as the hardware part is used, so like if I can use like deep sleep and be woken up by like a pin, external pin.
Right, behind the scenes they use.
Yeah,
behind the scenes they add this functionality. You know, like they don't have the RMT peripheral exposed on the S2 port, right? So you can't use RMT, but they use RMT internally for their NeoPixel library, right? So they do use the hardware peripheral. They just don't expose it to the user, so the user can use it.
Or for instance, the Pulse I/O that measures the length of a pulse. When you are using those ultrasonic distance sensors, for instance, you need that. It uses interrupts internally, but it doesn't expose them to Python.
Yeah.
Right, I guess you could always use the interrupts in the C module and
Sure. If you want to write your own, yeah. Cool. Okay, well, sorry, that was a jump in Python, but like Python's being used stacks in. Like I know some people or some companies that are making medical devices, that are completely running on MicroPython, which is, you think a medical device, medical and defense would be I guess maybe in space would be the really high end of needing really solid, reliable code base that, doesn't crash and doesn't.
I think there's a CubeSat that runs CircuitPython already.
Sure. Yeah. CubeSat's not quite the same level as, SpaceX or, like it. But yes, there's been Python in a lot of stuff, but it's definitely been taken more seriously now, which is really good. Yeah, in the commercial space. Okay, well, does anything anyone wants to chat about? Any questions from chat for any of our guests?
Bitlooney was asking about a quiz.
No, there's no quiz. No quiz. Sorry, Bitlooney. I have no butter left in the fridge, so no quiz.
Oh, I still got half a stick.
Half a stick of butter.
Yep, that's all I got left. I got to go buy some more.
Cool. Okay. Well, nothing else anyone wants to talk about?
Thinking.
No. Okay. Well, I think that could be a wrap then. It's going to be one of our shortest MakerCasts, less than 2 hours.
Close to 2 hours? That's fine.
Yeah, that's cool. Good. Sorry, Bitlooney, there's no quiz. No quiz. Keep butter in the freezer for emergencies. Can you freeze butter?
Yeah, you can freeze butter.
I guess we could play Draw.io like last time.
And then you can make a sculpture out of it.
You can make a sculpture. Okay. Cool. Okay, well, thank you very much for joining us this month. Thank you to all the guests. It's awesome, the projects you've been working on. Timon, good luck for the rest of the campaign. I hope you smash it through.
Check it out if you're interested in the P module.
And then fingers crossed, you'll be able to make them.
Yeah.
At the end of the campaign, there'll still be.
I'm eyeing on my inventory.
Yeah, cool, awesome. Thank you everyone in chat for joining, and I hope to see you all next MakerCast. I don't know who's hosting next, but we'll let you all know last minute as usual.
Exactly.
Okay.
Thanks for having
Thanks everyone.
Thanks everyone.
Take care.
Bye.